Hi, everybody. I'm happy to welcome you today to our live event. So, today I'll be speaking with Quentin. Uh, Hi, Quentin. How are you doing today?
Yeah, it's a pleasure. Doing great. And pleasure always to discuss about causal inference.
Good. Exactly. So, today we'll discuss the causal mindset, which is the name of Quentin's book, but it's also a concept, right? It's an idea about thinking causally, specifically when we're making important decisions in industry, but also in science and other fields. So, Quentin, could you maybe just introduce yourself, introduce your background, maybe a little bit, and then we can jump into the main topic.
Yeah, so I'm a trained economist. So initially I studied economics, and in economics, causality is key because you really want to understand the effect of policies, the impact on some tariffs, policies, for example, or understand causes of some problems. It could be even conflicts, it could
Introduce
be
yourself,
poverty, discrimination. And
introduce your
so
background.
causality is really basically well taught and advanced in economics. And you have two schools of thoughts. You have really people coming from computer science or economics and econometrics. So I come from this school of thoughts. And initially, I did research. I was in an academic career. I was basically doing empirical research where I was answering or trying to answer complex causal questions to help society and shape policies. So it was, for example, measuring the causal effect of sending weapons and the probability of conflict in developing countries, in particular in Africa. It was also measuring the impact of COVID lockdowns on the spread of the virus. And this will help to understand if you measure the benefits, you can compare to the cost. And that's the only way to make a good data driven, educated decision and reliable decision. And the more and more I advanced, I really thought that I always wanted to maximize my contribution to society, to help. I realized that really causal inference is widely misunderstood. It's really complex. So many people are shy away due to the math intensive parts. And that's when I started shifting a bit my mindset and help people also shift their mindset because researchers are really used to use causality also as just a way of thinking. Without any math and data, we'll naturally think about some problems, what challenge causal claims. And I started designing this causal mindset and making it more and more accessible. So I've been teaching this even to experienced people to be sure that they understand the concepts first, and then we go through the math. And basically, 1.5 year ago, a bit more now, I decided to fully leave my academic career and to basically share this with the world, with business world, with decision makers, with top executive, C-suite. And basically, I've trained over the last 10 years about 15,000 people, and now I train people in top tech companies and worldwide in different fields. So always about how to make better decision with causal inference, and it could be technical people where I really teach the technical side of things, or non-technical people where I bring this literacy and help them better question causal claim and make better data-driven decisions.
Great. Thanks for sharing. So, before we jump into the topic, so I just wanted to let everybody know that today Quentin and his team agreed to generously give away two editions of the ebook version of the Causal Mindset. So at the end, those that are interested, you'll be able to participate in this draw, and we're very excited to be giving away these books. So stay tuned for that. And also, the last part of the talk, as I usually do, is going to be reserved to questions. So we're going to go through a little bit of a Q&A session. So you can just, anytime during the chat, you can put your questions, and we will answer them live towards the end. Okay, so so I had the pleasure of reading your book, and one of the main theses or one of the main ideas is that traditional machine learning approaches rely on prediction, right? But you think that there is an element missing in those traditional prediction-based approaches, right? So maybe could you elaborate on this a little bit and how you think that we can do better than just using pure predictive models?
Mhm. So what happens is that many people know machine learning, AI, and predictive inference, basically. And the thing is, predictive inference can be incredibly useful. I mean, in your domain, for example, the medical sector, it's used to predict the risk of sepsis. So basically, an infection going wild and leading quickly to death patients. And this is particularly a problem for people who are vulnerable, like in intensive care units. And here you can just run an algorithm that will try to predict, to flag a risk. And you don't need to understand or use causes to do these predictions. You can even use symptoms or consequences, for example, a sudden rise in temperature. And this can be incredibly useful. This example illustrates that it can save actually human life to do prediction. But what is key is that we should always now basically update the mantra that correlation does not imply causation and reminds us that deep learning, machine learning, these models are for predictive inference, and predictive inference exploit patterns. You don't need to necessarily understand causal links to do good predictions, and it exploits correlations. So these models should not be used to infer causality. And this is particularly important because more and more people use machine learning. It's really everywhere. And it's sometimes counterintuitive to think that something that is a strong predictor is not necessarily a cause. And again, if we take the example of the sepsis, it's a good example why it will be very risky to misinterpret these coefficients. If you take the feature, for example, sudden rise in temperature, as a cause for sepsis or the problem that is coming, you might want to reduce the body temperature by doing maybe a cold shower, cold exposure. If you do this, you'll kill the person even faster. So the consequences are very dramatic. And it's the same in the business world. It's just this example is really dramatic, but you should not mix the two. So predictive inference is great. I mean, that's why you have top tech companies hiring armies of engineers doing predictive inference. You have one last example with this is if you think about all these top tech like Meta, Netflix, Spotify, Amazon, Booking, blah, 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 all these top tech, basically they have at the core of their business a recommendation algorithm and also social media platform. Basically, they recommend you some product you might like, a TV show, a pair of jeans, a next reel, and all these things are basically you don't need to understand why I would like a certain suit. They just want to show me something I might like. They really don't need to understand why I like it. So they don't need causality here yet. Yet. And we'll see in a second how you can combine the two and why it's the main thing I'm doing this day. So that's the first thing. You have incredibly powerful thing in the business world, in other sectors using purely correlational analysis and predictive inference. But you should not mix the two and make this heroic step, this dangerous step of interpreting the coefficient as causal, even if they are a very strong predictor. Now, the main thing I do these days is actually working with machine learning experts, AI experts, and companies to help them measure the impact of their predictive algorithm when they deploy it in production. If you want, when you do predictive inference, the metric to optimize your model is always the quality of the prediction. But this does not answer the important business or health question. What's the impact? Is it saving lives? Is it reducing cost? Is it increasing retention, conversion, sales? That's about impact. As soon as you say impact, it means cause and effects. So the main thing I do these days is really showing, which is exactly what top tech companies are doing, is that they are not just thinking, well, we have the top engineers and we pay them very well, so they will have their recommendation algorithm will work. They will test everything rigorously with causal inference, typically doing randomized experiment, A/B testing. They would show some version of an algorithm, a web page to someone, and a slightly different one to someone else with a different algorithm, for example, a different machine learning algorithm to optimize recommendation. And they have literally thousands of experiments every day at the same time, allowing them to precisely quantify the impacts and then make a truly data-driven decision where basically you can quantify the benefits and judge if it's enough to push in production. Because maintaining and deploying AI models, machine learning models in production is costly. So it's not enough to say it works. You need to really quantify this and compare it to the cost to see if you really want to push in production. So that's the first thing. You have two toolbox. Both are very useful. You should not mix them. And definitely you should them together. In particular, you should use causal inference to measure the impact of AI models, machine learning models in production. This is also valid for generative AI. If you want to measure the impact of your chatbot, you should use causal inference to measure the impact.
Okay, thanks for sharing. So if we boil this down, right, it's a reframing of the way we look at the questions we ask, right? Because we, I think the key word, right, we care about the impact, and just to maybe paraphrase or even quote what you just said, but impact is about cause and effect, right? And if we study the fundamentals of causal inference, we know that um, correlation is not causation, right? As you also mentioned, and we might have heard this a lot. So these correlations, while they can help us towards causation, if we don't have the causal mindset, right, the causal point of view from the start, well, we can be going down the wrong path, and you highlighted that with examples. So I know that in traditional what we would call predictive machine learning, um, I remember when I was a little bit younger, there was a lot. I mean, we still talk about this, but back then even more, we talked about like making the models explainable, right, and trying to understand like what is driving the prediction. And I don't know if you could maybe share a few thoughts on how the solution to this is causal, right? And maybe that we can get the answer like that.
Yeah, so this is very interesting. It's again, it's a very hot topic, and basically, it's exactly what I teach in my class, from prediction to causation. It's an online class, mainly for ML experts. And basically, here I mentioned also in the book there is one full chapter dedicated to this difference between predictive inference and causal inference. The thing is, when you do predictive inference, you exploit correlations again, and a strong predictor is not necessarily a cause. If you can explain the model, so you have two things also depending on the audience. You have things that are interpretable. An interpretable model is one you can directly look at the coefficients, for example, a ridge regression, and you can interpret directly the results to understand what is driving the prediction directly without additional steps. If you have more complex models, like deep learning models with thousands of parameters, eventually, it's very hard to interpret these parameters with several layers. So here you need some additional tool allowing you to explain the coefficient and understand what is driving the prediction. The thing is, it's still predictive inference, and the features that drives the prediction are correlational. And you can have very strong predictive power while it's not necessarily a cause. And I show this in the class. I could show code here and simulation, but maybe I'll keep this for another day. I'll share it otherwise. But I show this very precisely with within my class. I show that basically you have your correct causal model, allowing you to predict an effect. And then I include what we call a collider, which is basically a consequence from the other, from the cause of interest and the outcome of interest. And you include this in the model, and this completely messes up the estimation. All the coefficients are completely biased. And most importantly, you can see that one of the main driver is the collider. And the collider is, again, it's not the cause, it's a consequence from the others. So and from a predictive inference perspective, this last model, when you include the collider, in my example with simulated data, it's the one with the highest predictive power. And the collider is the strongest predictor. But from a causal inference perspective, even if you have a very high predictive power and this feature is a very strong predictor, highly statistically significant, it's completely wrong from a causal inference perspective. And that's usually one of the things that is shocking. So back to your question to conclude again on what you ask, making a model explainable or interpreting the result of a predictive inference model still do not mean that it's causal and that you can interpret the coefficient as causal.
Great, thanks. I fully agree, and I think um, the example of a collider is really a good one because maybe we could take just a step back and explain what we mean by something being causal, and this will should make it clear why the collider is not causal, right? And one way to look at causality, right, is that if we were to perform an intervention on a variable, this should modify a certain outcome, right? So if we think of the outcomes you mentioned, like revenue or something, a cause of revenue would be a variable that we're able to manipulate, that we're able to act on, for which a change in revenue will be expected as a direct consequence or as a consequence of this manipulation. But a collider, by definition, is a consequence of the outcome in this example, right? So if you think that, okay, this variable, this collider has an extremely high predictive power, which can be true, and you decide to act on the collider, well, the causal model will tell you this will do nothing to change your outcome because it's a consequence. You would need to act on the outcome to change the collider and not vice versa. So um, I think this is a great example, and the theory of directed acyclic graphs, which might be a little bit technical depending on your level of math and your familiarity with this, but this makes it very transparent. And I talk about this pretty early um, in my book, which is a little bit more math and stats focused, maybe than yours. But I think it really makes these things more transparent. And directed acyclic graphs, while the theory can be complicated, they're very visual. And I think just seeing the direction of the arrows in the graphs would illustrate your point very, very clearly. Um, Okay, next. So I wanted to ask you about some things you discuss in your book that I thought were very interesting. Specifically, the example of the cold shower. I don't know if you we could take a few minutes to talk about that because while this is not like a business problem, I think it shows like how we can be misled, and specifically when we don't understand the mechanism. So maybe you could tell us a little bit about
Mhm.
the cold shower experiment and what would be a mechanism in this context and why it's important.
Mhm. So, in broader term, indeed, I might be too technical today because I'm seeing you, and we used to exchange, I mean, online on technical terms. But of course, I can tune down the technicality because that's also the book has no. It's really made accessible. If you never heard any of these terms, it's made accessible, and that's also the type of content I create sometimes. So, cold showers and mechanism. Something that is key, and that even sometimes is surprising to some people practicing causal inference, is when you measure a causal effect. You say, okay, this is the cause. And you have, for example, a randomized experiment allowing you to really identify well the cause. The thing is, does not necessarily explain the how. It answers the why this is the cause, but not necessarily the how. What explains the pathway? And in causal inference, it's kind of a second step. You try to understand the mechanism, the pathway, the how. And understanding the how is very important. That's something I discuss a lot. Later, we can discuss this about AI and with businesses. It's particularly important when you deploy a chatbot to understand what is driving, not only what is driving, but what is explaining the pathway. I'll come to an example later. let's keep on track and get back to cold showers. If you look for cold showers and evidence about cold showers, in particularly on work-related sick leave, you'll find probably this very famous paper, which is published in a quite good journal. It's PNAS, plus one, sorry. And basically, if I'm not mistaken, it's a large experiment. 3,000 people in the Netherlands. And basically, you have four groups, but to simplify, let's say two. You have one who has to take normal showers every day, and the other group is basically taking normal showers every day, plus a cold exposure at the end. So putting the water cold at the end of the shower for different time, 30 seconds, 60 seconds, or 90 seconds. And the main punchline, the main result of this paper that I've heard the first time in the documentary is that the people who did the cold showers, the treated group, had a reduction in work-related sick leave of something like 33%. A large effect size, very large magnitude. And as usual, when I hear causal claim, it triggers me. I look in the paper, start reading it. The first thing that came to my mind was the placebo effect. Basically, the first thing here about the mechanism, what explains this effect. Is it a placebo effect? Just because you're taking the cold shower, you feel stronger, but there is not really something happening within, just like more mental a thing happening. And that might be an effect. Honestly, I don't have big issues with placebo effect. Here, if you don't, as long as you don't have a side effects, negative side effects, good for you. If you feel better, it helps you just to boost you through the effect of a placebo. That's okay. First, in the paper, they mentioned this 3 paragraphs before the end of the paper. I think this should be in the abstract, in my opinion. That's just a detail. But the second thing, if you go deeper, and again, here you can do this without a single equation. And I know that this will trigger many people, but you can really question things just with your mindset. For example, if you know a bit about experimenting and pathways, in the paper they explain that we miss the mechanism. Basically, we are not even sure what could explain the effect of cold showers. There are things that are studied, there are direction, but it's not yet very, very clear. So if you don't know the mechanism, it's even harder to argue that it's following a precise mechanism. But the more severe problem in this research, I would say, is what we call, so the complex terminology is called Hawthorne effect. It's basically when you observe people, you change their behavior because they know that they are observed. And this might have devastating effect for our research. For example, here, in my opinion. Why? Here in particular, you could say aversion is a desirability bias, is basically people who enrolled in this study are all volunteers. So probably they know that we expect them to be more resilient, stronger, that cold shower might boost their immune system. That's the expectation. And hence, because they are observed, they might simply think, okay, I have to go to work. Because I'm in the treated group, that's what we expect from me, I have to go to work. But if this is the pathway, it's devastating for the research because it means there's no effect. It's just because you observe the people, they behave differently. It's not an effect of actual cold shower, it's an effect of experiment on cold showers. So that might be a very big problem. And of course, I would like also just to end with a more encouraging note because to avoid people thinking that I just criticize things. First, I think it's an interesting research for some aspects. It brings some kind of answers. And the second, with limitations and caveats, which is usually the case with research. But second, I also suggest potential solutions. I mean, you could track, there's no placebo to cold showers, that's for sure. But you could track some metrics that are objectives with many, maybe smart watches, even blood samples, to see if you actually have something happening in the physiology of the person. I don't have maybe the right terminology, but really something happening in the body that you can track objectively and that can't be manipulated because in the study everything is self-reported. So again, I like to show this example for several things. It illustrates, as you said, that the pathway is very important to understand. It's kind of a second step. And second, that you can challenge peer-reviewed research without a single equation.
Thanks for sharing. So there's a few points I just want to piggyback on here because what you just ended with this idea is something that I encounter too in my practice and in my training, where we have these, for example, in pharma companies, we have these medical experts that feel sometimes overwhelmed or that feel uncertain or that lack the confidence to really dive deep into the numbers, right? They don't have a training, they're not um, they haven't developed a skill to read and write equations like other disciplines have, so they can easily feel like, oh, maybe I don't know, I don't have the correct point of view to understand this. But I think that's completely wrong. And I think you agree here that there is so much that we can do to criticize or to, and maybe criticize is too negative, but to evaluate or to judge the quality of evidence without even getting to numbers and without even, let alone equations, just even before looking at numbers, all these design aspects, these common sense aspects. Um, there's no placebo for a cold shower. There's also, like you said, everything is self-reported, et cetera, et cetera. These are all things that undermine the credibility, but we need to kind of judge the overall package of the evidence, right? There's some strengths, some weaknesses, and before even looking at the numbers, we can arrive at a sort of judgment just based on our common sense, our scientific knowledge, but also on our domain expertise, right? If we have a deep understanding of immune system, we might say, well, I don't, there's no plausible mechanism that I know, so that can increase your level of skepticism, etc. So I think that's a very important point, to empower people to um, have a judgment about the quality of evidence. And then the second step, obviously, the numbers and the methods that we use to
Hmm.
get these results quantified are important. And then obviously, we're both quantitatively trained, and we see the value in this. But I think it's good to take a step back for to understand the power that we have there.
Hmm.
Um, and then I just wanted to just highlight a few elements of this that I think are fascinating, that we touched upon. The lack of placebo, right? It's like in traditional clinical trials, you want to blind people to the treatment, but here it's like you cannot blind someone to getting drenched in cold water. It's like you will know. I can say no, no, this is a placebo, but you will feel that the water is cold. So that is a problem with that we can't really avoid. So we need to be clever in other aspects of the research, and I think that's what makes these things fascinating, right? It's like, yeah, it's easy to say like, if everything is perfect, this is what we need for a causal claim, but we never, almost never have that, and this is where there's like creativity, right, in how we approach these questions, etc. So I, I'm really happy to share this example, which is one that you discuss in the book, and I really loved how you approached it, especially because it's a pretty hot topic on social media, right? Like sometimes I take cold showers and it feels good, but does it really
Hmm.
help my health? I don't know. It just, I feel good after taking it, and to me that's enough, right?
Hmm.
Um, okay, so next I wanted to maybe take the last minutes before the Q&A, which will start in roughly 10 minutes, um, to discuss the more of a business problem that I think is very hot topic today, and even Marcio in the chat mentioned it. Using evaluating LLMs, right? Like, um, so I've heard, I've been approached by people who have these problems, right? They're implementing either AI agents or LLM based workflows, and they want to evaluate how, what are the results of this, right? So I don't know if maybe you could just share a few words about first how we could start to think about this problem
Yeah.
if it's tractable, and second, um, how does causality and LLMs fit together?
Mhm.
So I know
Yeah.
this is a
Thanks a
big
lot.
topic, but
Yeah. So just to be sure, you want to know how to measure the impact of deploying, for example, an LLM.
yeah.
Okay.
So that's the
Very good.
first part, and then the second part, if we
Yeah.
still have time, is how causality fits into LLMs.
Okay.
Yeah.
Yeah. I thought the second part. That's why I wanted to answer. Yes. Okay. So first, because it's just 10 minutes, I also let's know the audience that Monday I'm doing a full conference, free conference online, 1 hour and a half, exactly just on this.
Do you have
It's
a
on
link that
Pact.
we could share?
So it's organized by Pact. I think I will share tomorrow the link, but
Yeah,
it will be on my social media on
we'll
LinkedIn.
share it in the comments of the live event too.
Yeah, exactly. So this I have the link here. I can share it. I'll do it afterwards.
Okay.
Okay. So back to this. So as I like to say, causal inference is the answer to this $1 million question. Is you want to know the impact of deploying a causal, sorry, a chatbot, an LLM internally. Causal inference is the answer. I mean, if you want to measure the impact, that's the most reliable way to do it. But as I witnessed in my practice, something that I thought I'll never say is causal inference can be misleading. And in particular, it's not really causal inference, it's rather how people set up their experiments and sometimes overinterpret the results. And so, causal inference is the answer. It means that you can do randomized experiments in some context. Sometimes you can give the chatbot to some users, not to other users, and really compare. Sometimes you use more quasi-experimental methods. It's basically you deploy the chatbot at one time in a region or in different region or in all your region, in all your offices, but at different point in time. And you can use these differences with causal inference to measure the impact. But now I want to add, because this is the obvious answer, that's obvious to us, but it's still underused, sorry. But what I do the most in these talks and with companies is tell it can also be misleading if you don't do it right. In particular, I classify the mistakes in three categories: misunderstood pathway, misleading extrapolation, and external validity issues. Long story short, usually these framework allow you, and it's chapter 8 of my book, it allows you to pin down the potential issues and solve it by basically tracking the right metric or set of metrics. Let me give you the most obvious examples based on my practice. If you deploy a chatbot, usually there is a net time heterogeneity. It means the effect change over time. For example, in the beginning, you might learn how to use the chatbot to help you, and it might improve the work of your customer service if they have now access to a chatbot to find information. But they learn and they get better and better. So in the beginning, if you just focus on the beginning, maybe the effect is positive but small. If you wait a bit, there is a learning effect and it gets better. But what interests you is eventually the long-term effect. And we know, see, that also that we have this tendency to fall asleep at the wheel with AI. Once we are used to AI, generative AI, the chatbot, we become eventually lazy. We over rely on AI, and then the performance might degrades just because people are less diligent. It's not even the tool that is changing; it's really the way we use the tool, and hence. I explain how tracking over time this time of effects, studying this is necessary to really answer the right question. You also have, for example, sometimes you just track the impact on short-term metrics, but you want the impact on the longer term. For example, you give your marketing team some Gen AI tool that help them write content and they can flood the internet with contents on social media. And hence, they will typically, traditionally focus on followers counts, impressions, interactions. All these metrics might go up. But then I really always combine causal inference with system thinking. That's not the right question. Why do you want more followers? It's not about followers. You want long-term growth. And the thing is, these strategies where you use Gen AI to create content might harm on brand loyalty. It might create trust issues from the customers and loyal customers, which is very destructive in the long term. And then just flooding the web with more content that will mechanically kind of drive impression and up and follower counts is probably a destructive strategy if you look at the right metrics. So again, there are technical solutions to these problems. The last one is about understanding the pathway, what drives the effect, what we discussed. For example, you have your, again, customer service, and you don't replace them with a chatbot. You just give them a chatbot to help working. You deploy this, you A/B test, and you see that the people in your customer service who have access to the chatbot are performing better. They solve problems faster, they solve more problems, and so on and so forth. And you say, great, you pop the champagne. But the thing is, what might happen is just a motivation effect. Now the customer service feel, okay, our management deployed a fancy AI tool, and they are just more motivated, which improve the quality of their work. They put more effort. If it's the case, it might be short-lived. And here again, by tracking the right metrics, first by identifying this different pathway and tracking the right metrics, you can disentangle the different stories and then answer these complex questions and know if the effect is probably short-lived because it's just a motivational boost, or if it's actually you boost the quality of the work and make it more efficient, and hence this is a good decision and you might decide to deploy fully. So these are the main thing. And to summarize, yes, causal inference is the answer, but you should do it right. And it's relatively subtle when you want to measure the impact of AI because it's really a multidimensional tool.
Yeah, thanks for sharing. So, we're actually right on time. I think that's great. So we have 20 more minutes that we wanted to give to the audience. So right now I see there's many people here, and we already have a few questions. So I would invite you to put your questions in the chat. We'll answer them one by one, and if we don't have time to answer them, I'll answer them by responding with a written comment after the talk. But we have 20 minutes, so we should be able to do a handful of questions. So please share them. And also, if you missed it in the intro, I just want to remind everybody that Quentin and his publishing team have generously agreed to give away two e-copies of the Causal Mindset book, which was released shortly a few weeks ago. And so anybody who would be interested in that book, you can let us know in the comments, and you will be able to participate in the draw that we will hold after the talk. So I'll read out the questions. So we had a question from Marcio, who says, today many people are using LLMs to make decisions, but LLMs don't understand causality. Do you think causality is the only thing missing to LLMs can make decisions?
So thank you, Marcio, and that allows me to actually answer the final topic I didn't cover, and I still had it, and I wanted to first take a break. But well, long story short, let's go. So LLMs are used more and more in causal inference to help us question causal claims. First, basically at the foundation, when you want to ask a causal question and build a causal model, you have to build this causal graph that Justine mentioned. And for this, you need a lot of domain knowledge. You really need to understand what is causally related. If you have a marketing campaign, the competition behavior, is it reacting to our ad campaign? Is it a cause? Is it both? What about seasonality? And you really need a lot of domain knowledge. And LLMs have a lot of domain knowledge. And basically, this can help to build the graph and challenge the graph. So basically, you can use any chatbot frontier model to help you question causal graph and build causal graph. You even have now a lot of research. Like there is one paper called Mining Causality, another one ACLM paper that shows how to do causal discovery augmented with LLMs. And basically you have some papers, long story short, that structure how to prompt to use LLMs to help support our causal inquiries. You even have now a Python package, which is called PyYLLM, where basically within Python, you can call an LLM to ask questions. So that's the first part. You cannot measure causality with LLMs, but they have a good sense of what might be a cause and how things might be related. And that's how I built a free app, basically based on ChatGPT. I want to move to Claude, but it's not done yet. A free app that's available on my website and within the book, where basically you share a claim and you challenge the findings. So that's the first thing about LLMs. The second about decisions. So anytime you think about AI, it's also a causal question. It's always comparing to the right counterfactual. So, for example, what I mean by this is that LLMs are doing mistakes, but humans as well. And the nature of the mistakes, for example, for making a decision, are different. Humans have personal bias, emotions, friendships, enmities, personal agenda, which create mistakes. And this is very different from the mistakes from AI when they have to make decisions, Gen AI and LLMs, which sometimes is just hallucination, overconfidence, or sycophancy. Basically, they really want to satisfy you. And what I witness is that you really have to test to detect the nature within your context of the errors and compare it to human errors, and how basically you can work eventually limit these issues. So without more context, unfortunately, I cannot answer less generally and more specifically, but that's basically my overall take.
Good. Thanks for sharing. And also, just want to remind that you told me you told us a few minutes ago that you'll be giving a talk very soon about these topics. So if anybody's interested, it's free to join, or how could they
It's
join?
free to join.
Yeah.
I put in our chat
Okay.
the link now.
Okay. So
So on the page, it's probably scheduled for 4 hours for some technical reason, but it will be 1 hour and a half. If you're based in Central Europe, it will be at 2 p.m. Monday CET,
okay, perfect.
Central European time, and it's free.
So I shared it. If you could let me know in the comments that you see the link for Quentin's upcoming talk, um, and in the meantime, we'll move on to the next question. Again, reminding everybody that we're going to be giving away 2 copies of the book. So if you're interested, just let us know in the comments. Okay. I'm sorry, just looking for the questions. I had a little technical issue here. Okay, so thanks for the question, Marcio. There's also very interesting comments that I would have liked to read out, but we don't have time. Um, so, how do you validate a causal bag in practice when you don't have domain experts available? So, I have a few thoughts about this, but maybe you could start off and tell us what you
Mhm.
think.
Yeah, so it's definitely a complex question. So I think here, if you don't have domain experts available, the best you have will be typically generative AI, or you also have, it depends the question again, but maybe let me try to give different context. Um, you also have like more and more knowledge graph that are built from scientific literature. So basically, you have different researchers who take tons, thousands of published papers quantifying causal links, and then they try to build these graphs, allowing you to have a quite reliable set of graph with some uncertainty, of course, suggesting causal pathway. But the thing is, you'll see very quickly that when you want to try to the thing is with graph, and let me add this very important thing, it's you're all it's hard to be really certain about something. And the thing is, usually you will start, the main thing is to control for what we call confounders, which is common causes. And the thing is, the further you go down the list of potential confounders, probably the higher, the more uncertain you are. And the thing is, if you make one mistake, it can completely mess up the estimation. If, for example, you include something that should not be included, like a mediator or a collider again. So sometimes it's a matter of focusing on what you're certain, and you stop when you enter the risky zone. Basically, it's this 10th potential confounder, and you're uncertain if you should include it. But at the same time, if you include it, you might also create more issues. That's solving some issues. And this is definitely a complex one. You have to support your domain knowledge, or the lack of here, and this process. You do have data-driven ways. So there is this entire field called causal discovery. The goal is you feed in data, and it tries to uncover the graph based on some relatively more or less strong assumptions. This again will, I would say, in practice, domain knowledge, if you have it, always dominate. So for example, if you see something that's revealed with the data with causal discovery, that really goes against what you know, and you have hard proof and long history, usually domain knowledge will dominate. But if it's lacking, this is definitely an interesting tool. Of course, in practice, that's not that trivial. You can look at the book of Alexander Molak. You can probably contact him to discuss more about causal discovery. Martin Huber have also a very good paper. It's called Introduction to Causal Discovery. It's available on Archive. It's a good first read for causal discovery. Last comment on this is, for example, if you use panel data, things that are moving over time with different observation over time for different individuals, it's becoming way more complex already. And in the vast majority of situations, I work with panel data. So that's why it's in practice way harder to actually implement in my settings causal discoveries. So, and Justin, you wanted to add
Yeah, I mean, I think this shows also the different areas where we tend to work in, right? Because in business, right, things move very fast. You know, like sometimes you're lacking this domain knowledge of a certain process, and in business also the system you're studying to understand the cause and effect relationships is can be typically shifting over time, right? How consumers behave, how they react to new features, or how they react to sales, or how they react to marketing efforts. This is something that changes over time, right? Pretty quickly. So I think there we need to be creative and try to piece together these tools like you mentioned, right? We can use LLMs, we can use causal discovery, we can use a whole bunch of tools, knowledge graphs to help us fill in these blanks. I think in the areas where I tend to work is we have more of the domain knowledge, and the difficulty is in extracting it accurately. And I think the point you make about trying to limit yourself when you're starting to enter the gray zone of I don't know what is the causal relationships of these of a particular variable in my system, should I include it in my models, etc. I think also one tool that is interesting is to do like a sensitivity analysis for hidden confounding, which is not super complicated, given that we have packages to do that. And this can tell you how much of confounding you would need to completely eliminate your effect, or other sorts of sensitivity to assumptions that can be quantified. So,
Yeah, on this, I really recommend the latest framework by Carlos Cinelli, ASLET, Making Sense of Sensitivity. It's a beautiful way, and a very accessible way with simple metrics to do sensitivity analysis. So again, it's called Making Sense of Sensitivity.
thanks for sharing that. I had it on my list. I didn't read it yet, but now that you recommend it,
No, it's amazing. It's really groundbreaking, in my opinion.
okay, thank you. Um, then we have a question. The next question. So we still have time. Great. how could we develop experiments in business context? What should I need to study or know for this?
Okay, so you need to study causal inference, and there are several free resources for this. For example, you can start by reading Mateusz Fakure, free ebook called Causal Inference for the Brave and True. This will be a short read, a first read with Python code, allowing you to understand causal inference, to understand the idea of an experiment, an A/B testing in the business world, and the fact that you can also do infer causality with observational data when it's not possible to randomize the treatment to do an experiment. And it's also in the book. So that will be the first step. If a slightly more academic take is the free book by Scott Cunningham, which is called The Mixtape, and you can also access it everything online today, even right now, without login, without anything. And you also have Python code, but in this book you also have R and Stata code. Once you've read these, you have a first foundational knowledge. I mean, Mateusz Pacoria has even a more advanced book that you have to pay for. It's Causal Inference in Python, which is really more business oriented. And if you go deeper in the technical aspects and recent models, you can even read also another book that is free. It's about causal machine learning, really advanced methodologies. It's called, you can go on Causal ML or Causal Book, causalmlbook.org. And it's basically a book by Victor Chernozukov et al. So that will be the first step. I will recommend you to start reading and acquiring this. I can only encourage you also to get my book because it's really oriented as this first step as well. And there's a lot of business examples where basically it shows how to apply already the mindset. And this is the first step. Usually when I work with a company, I always tell, if it goes bottom up, it's basically data scientists coming to me. I always say, okay, let me talk to the executive first and to everybody in the room to be sure that everybody has the right literacy terminology and they can communicate. And once you create this within your company, if you've done it efficiently and you have people who really want answers, they will want more. And they will then give basically the resources to upskill the team if you need these tools.
Great. Thanks for sharing. And also, I just want to add one slight point, and before the next question, so I think these are all great tools, and just a really like might be a simple detail, but in the question, how could we develop experiments in business context? I mean, probably you know, but the obvious first part is to have a question to answer, right? You don't you don't just like experiment for experimenting. You want to understand something, and then you use causal inference frameworks to formulate a method to answer the question that will be as rigorous as possible. And there's a whole bunch of tools and methods that you can discover in the resources that Quentin mentioned.
So to build on this and to make very short, basically next time you hear in a meeting, a business meeting, therefore or because, and someone's pointing at numbers, that's basically there is a causal claim. And maybe you want to go beyond this correlational evidence that has been showed, and you want to experiment to actually get the answer. ROI should be a causal metric. It's a return, a consequence of an investment, a cause. That's it.
I love it. Okay, so the next question. If you use archival data and ML to determine who benefits from a treatment, which treatment, and potentially treatment dosage, switching treatments, how can you make causal conclusions? What can help to draw causality? So,
It's really to start, not to start with machine learning, but really to start with causal inference. You have to build the right model. And this is typically what I help people figuring out, because if you're asking these questions, obviously you're literate in data science and in machine learning and in predictive inference. But again, if you just try about this prediction, you'll see association. It's the same thing if I say using medical data, I can say, and this is that grip strength is a very strong predictor of heart health. Yet, you have this BBC article using this research saying, okay, here are 5 ways to train your grip strength. But that might be with a very small effect, very marginal effect, even maybe no effect. The relationship is probably entirely driven by other factors, by the fact that fit people who are more athletic, who are doing sport, have better grip strength. And the effect comes from strength training, cardio, and all these things, and not grip strength directly, even if it's a strong predictor. So within your setup, if you don't start with the right mindset and structure and causal framework, it won't answer the right question. So what you can do is eventually start with a causal discovery algorithm, if you have a lot of data, to start seeing this, and then apply a causal inference model that allows you to quantify each of the causal links to see what is driving the results. Last point, I want to point to these resources also. If you're in the medical sector, usually what we care about is not just the average effect, but we would love to have the individual effect. Basically, you don't want just the average effect for a population, but you want to know for this person with comorbidity factors, with certain specific traits, what's the expected effect of a treatment. And if you have a lot of data, you probably can measure what we call heterogeneous treatment effects, which is with some algorithm, for example, called Causal Forest. And I highly encourage you. There is a beautiful paper by Stefan Feuerhögel and other in Nature Medicine. It's like uh, causal machine learning for treatments, for predicting treatment outcome. Causal ML for predicting treatment outcome. I really recommend you to read this from Nature Medicine. It's very accessible. It's really just explaining the gist.
Thanks. So all these resources, if you don't mind, could you share them to me and we share them with the audience after? So we're gonna slowly wrap this up. We still have a few questions, so I'll be happy to answer them after. But the hour has come up. It was really great to have you and everybody that engaged. Thank you very much. Thank you, Quentin, and we'll be drawing the book prize winners. So there's a handful, maybe 10 people that expressed their interest. So if you're interested in the book, you can still comment your interest and we will draw from you. So thanks a lot, Quentin. It was really great. I hope you enjoyed it too.
Thank you, everyone. Have a pleasant evening. Cheers.
Bye.